Hi everyone, welcome to Savi channel. In today's class, we are dealing with new module 4, which comes under machine learning with Python under VTU curriculum, subject code 18EC745. So what we are going to learn today? So we are going to learn today a Basilian learning. So these are all the contents which we are going to cover it, and you can refer my notes in subject block 18EC745 svat.boxplot.com. So before proceeding, we have to know what is Bayes. Bayes theorem. Bayes theorem is named after an English mathematician, Thomas Bayes, who worked extensively in decision theory. So basically, when you come for machine learning, decision theory is very important algorithm or a steps which plays a vital role. Okay, so this comes under your probability also. Bayes theorem is also used widely in machine learning, where it is very simple effective way to predict the classes with the precision and accuracy. So once you need any precision and accuracy, we go for Bayes theorem. The Bayes method of calculating conditional probability is used in machine learning application that involves classification of a task. Okay, very simple way if you talk, the Bayesian theorem, known as Naive-Bayes classification, which is used to reduce the computational time and a cost. So what is the important here? We have to note down, it's reduce the computation time and a cost. Okay. The next topic, why use Bayes theorem in machine learning? The Bayes theorem is a method to determine the conditional probabilities, that is, the probability of event occurring with a given that another event has already occurred. So this is the concept they are going to use it, because a conditional probability include additional conditions, in other words, more data. So more data will be implemented to get a more accurate result. So thus, like conditional probability are must in determining the accurate prediction and probability in a machine learning. It is obvious that we have to go for accuracy and predict your result. We go for Bayes theorem. So based on this, we have machine learning of two different reasons why we are Basilian learning methods are used. First Basilian learning algorithm that calculates explicit probability for all hypotheses, such as Naive-Bayes classifier, are the most practical approach to the certain type of learning problems. The second reason why we are going for Basilian learning method is to provide useful perspective of understanding many learning algorithms that does not explicitly manipulate probabilities. So ultimately the agenda is that it is used for learning methods. We could have seen a lot of learning methods in the previous sessions, but still when you go for practical approach, accuracy wise, cost effective wise, we go for a Basilian learning method. So features of Basilian learning methods. The features which we are going to see is each observed training example can incrementally decrease or increase the estimated probability that a hypothesis is correct or not. So in the previous module, we have saw the solvation of hypothesis, and we are going to have a prediction on it. Okay, so here what we are going to do means we are going to have a estimated probability that a hypothesis is correct or not. This particular hypothesis correctness will give you more flexible approach in learning than algorithm is completely eliminated hypothesis if it is found to be inconsistent. So here you are going to eliminate the unwanted training data sets or training sessions. So in this also we should know the prior knowledge can be combined with the observed data to determine the final probability of your hypothesis. So prior knowledge, so what type of data you are providing, what type of training you are going to do it, and how many times the iteration I have to done it or I have to do it. So these things you should have a prior knowledge. In Basilian learning algorithms, prior knowledge is provided by asserting a prior probability for each candidate hypothesis, a probability distribution over the observed data for each possibility or possible hypothesis. A Basilian method can accomplish hypothesis by taking or by making probability predictions. So one we have to keep in mind, the probability prediction can be done with the Basilian method. A new instances can be classified by combining the prediction of multiple hypotheses weighted by their probability. So what happens, every time number of iteration if you're doing, okay, with the Basilian learning method, a new instances can be classified very easily. Okay, so this is how you can optimize the decision making against which other practical methods cannot be measured. So optimization technique is very important in the Bayesian learning method. So we have talked about the advantage, we have talked about the how the optimization technique can be used. Okay, here one thing we have to remember, the practical difficulty in applying Basilian method. Two things which we have to encounter with the practical difficulties with a Basilian method. The first one is a typical required initial knowledge of many probabilities. When these probabilities are not known in advance, or very rarely if you are understanding the probability of this one, it's very difficult to estimate the background or to manipulate your data, and you cannot assumption according to your requirement. The second difficulty, practical difficulty, is that significantly computational cost required to be determined by Bayesian optimal hypothesis in general cases. Okay, so in this way the two practical difficulties may occur in a Bayesian methods. So thank you very much for listening. So in the coming session we will be having a Bayesian theorem.